Hi, this is teacher Karie. In this video, we are going to discuss rational functions. This is Module 2 of General Mathematics for grade 11. This video is anchored on the content standard where the learner demonstrates understanding of key concepts on rational functions, and on the performance standard where the learner is able to accurately formulate and solve real-life problems involving rational functions. After using this module, the learner is expected to represent real-life situations using rational functions, distinguish rational function, rational equation, and rational inequality, solve rational equations and inequalities, represent a rational function through its table of values, graph, and equation. Find the domain and range of a rational function. Determine the intercepts, zeros, asymptotes of rational functions, and to solve problems involving rational functions, equations, and inequalities. In this lesson, the essential understanding is that learners will understand that the concepts of rational functions have wide applications in real life and are useful tools to develop critical thinking and problem-solving skills. The essential question to be answered is, how does the concepts on rational function facilitate in finding solutions to real-life problems and develop critical thinking skills? Are you ready to begin? Let's get started. Explore your understanding. This exploratory activity will present to you the basic concepts of rational functions, equations, and inequalities. Activity 1. Read the given situations and answer the questions that follow. The distance from Manila to Baguio is around 250 kilometers. The first given average speed in question A is 25 kilometers per hour. How long will it take you to get to Baguio if your average speed is 25 kilometers per hour? To solve this, recall that the formula for average speed is equal to distance over time. Since we will be solving for time, the equation we will use is time is equal to distance over average speed. Substituting 250 kilometers to distance and 25 kilometers per hour to average speed, we get 10 hours. It will take 10 hours to get to Baguio at an average speed of 25 kilometers per hour. Can you do the same if the average speed is 40 kilometers per hour, 50 kilometers per hour? Pause the video before self-checking against the correct answer. If you got 6.25 hours, that is 6 and 15 minutes and 5 hours respectively, then you are right. Pause the video so you will have enough time to answer the second question and submit your solution with explanation and final answer to your teacher. Activity 2. For part 1, we need to determine whether the given is a rational function, rational equation, or rational inequality. Recall that a rational function is any function which can be written as the ratio of two polynomial functions, where the polynomial in the denominator is not equal to 0. The domain of f of x is equal to p of x over q of x is the set of all points x for which the denominator q of x is not 0. A rational equation, on the other hand, is an equation containing at least one fraction whose numerator and denominator are polynomials. These fractions may be on one or both sides of the equation. A rational inequality is an inequality which contains a rational expression. Now that we have the definition in place, We first look at the odd-numbered items in part 1. Number 1 is a rational equation. Number 3 is a rational function. Number 5 is clearly a rational inequality. Number 7 is another rational function. Can you explain why? Use the same ideas to answer and explain the even-numbered items. For part 2, we need to determine the value of x that makes the term undefined. Recall that undefined is an expression in mathematics which does not have meaning and so which is not assigned an interpretation. For example, division by 0 is undefined in the field of real numbers. Looking at example A, we get x equals -1 by equating the denominator x plus 1 to 0 and then solving for x. The solution is shown on the left side. X plus 1 equals 0, thus we get x equals -1. For example B, when we equate the denominator x to 0, we get x equals 0. For examples C, when we equate the denominator to x minus 1 to 0, we get x is equal to 1/2. Pause the video and try to answer the odd numbers. If you answered x equals 2/3 for number 1, x equals 3/4 for number 3, x equals 0 for number 5, and x equals 0 for number 7, then you got it right. Very good. You can now answer the even numbers and submit it to your teacher. Let us now focus on the main topic of this module. A rational function is a function in the form of y is equal to f of x is equal to p of x over q of x, where p of x and q of x are polynomial functions and q of x is not equal to 0. A rational equation is an equation containing at least one rational expression, p of x over q of x. Moreover, if the equation symbol equal sign is replaced with less than or equal to, greater than, or greater than or equal to, you have a rational inequality. In solving rational equations, we can clear the fractions by multiplying both sides of the equation by the least common denominator, or LCD, or we do cross multiplication. For example A. Solve for x in x minus 1 over x plus 3 equals 5. We can multiply both sides with the least common denominator, x plus 3. Thus, we get x minus 1 equals 5x plus 15. Simplifying, we have x equals -4. Example B. Solve for x in x plus 1 over x minus 2 equals x minus 1 over x plus 3. Since there are rational expressions on both sides of the equation, then we can do cross multiplication. Thus, we get x plus 1 times x plus 3 equals x plus 1, x minus 1 rather, times x minus 2. Simplifying, we get x equals -1 over 7. Is everything clear about solving rational equations? If yes, then that's great. If not, you can watch that part of the video again just to make everything clearer. This time we are going to solve for rational inequalities. In solving rational inequality, we need to determine over what intervals the rational expression takes on positive and negative values. These steps below, 5 steps, are shown clearly in the example. Example C. Solve for x when x minus 1 over x plus 3 is greater than 5. Looking at example C, it is similar to example A, but instead of an equal sign, we have a greater than sign. The first step in solving rational inequality is to solve using the equal sign, then locate the x value on the number line. So we get a solution similar to example A, and get x equals negative 4. This is our first critical point, and it is also shown in this number line. The second step is to determine the x values for which the rational expression is undefined, and then locate the x value again on the number line. To do this, we need to equate the denominator to 0. Thus, we get x is equal to negative 3. Since this is the value that will make the term undefined, hence, x not equal to negative 3. Plotting this on the number line, we get this hollow circle. This is now our second critical point. The third step is to use a shaded circle to indicate the value is included in the solution set and a hollow circle to indicate that the value is excluded. These numbers partition the number line into intervals. In this case, 3 intervals. The first interval, the second interval, and the third interval. Since the critical points are solutions that are x is equal to negative 4 and x not equal to 3, we plot these points with open circles. Our possible solutions are x less than negative 4, x greater than negative 3, and x greater than negative 4 but less than negative 3. Next, we select this point and substitute the given rational inequality. If it makes the inequality true, then it is the solution. So let's try the first interval x less than negative 4. Let's have a test point of negative 5. You can use any test point, but the nearest test point is negative 5. Substituting it to the rational inequality, negative 5 minus 1 over negative 5 plus 3 is greater than 5. We get negative 6 over negative 2 is greater than 5. So we have 3 greater than 5, which is false. Therefore, this interval is not the solution or is not part of the solution. Next, we test this interval, x greater than negative 3. Let's have negative 2. Negative 2 minus 1 over negative 2 plus 3 is greater than 5. Negative 3 over 1 is greater than 5. So we have negative 3 greater than 5, which is also false. Therefore, this is also not the solution that we are looking for. The last interval that we're going to test is the middle interval, where x is greater than negative 4 but less than negative 3. Let's have negative 3.5 as our test point. Negative 3.5 minus 1 over negative 3.5 plus 3 is greater than 5. Negative 4.5 over negative 0.5 greater than 5. We get 9 greater than 5, which is true. Therefore, this is the solution that we are looking for. Again, the fourth step is to set the test points. If it makes the inequality true, then it is the solution. Looking at our number line with our intervals and our critical points, we have figured out that the answer is x greater than negative 4 but less than negative 3. Is everything clear about solving rational inequalities? If yes, then that's great. If not, you can watch that part of the video again just to make everything clear. It is important to note that the following concepts are very important so we can fully understand the nature of rational functions and eventually have an easier time graphing these functions. The domain of the rational function f of x is the set of real numbers except those values of x that will make the denominator 0. In set notation, domain of f is equal to all values of x such that x is an element of real number except x equal to a where q of a is equal to 0, or all values of x such that x is an element of real numbers where q of x is not equal to 0. The range is the set of all values that f takes. The intercepts of a rational function is a point where the graph of the rational function intersects on the x, that means it's an x-intercept, or y-axis. The zeros of the rational function described by setting the numerator equal to 0. There are three types of asymptotes: the vertical, the horizontal, and the oblique. A rational function will have a vertical asymptote where its denominator equals 0. A rational function will have a horizontal asymptote when, if the degree of the numerator and the denominator is equal, we use y is equal to the ratio of the leading coefficient. B, if the degree of the denominator is lower than the degree of the denominator, then we use y equal to 0 as our horizontal asymptote. If the degree of the numerator is higher, no horizontal asymptote but an oblique asymptote exists. So let us look at the example given. Let us determine the domain, range, y-intercepts, zeros, and asymptotes, as well as construct the table of values, and then eventually we will be able to sketch the graph. Look for the domain. We equate the denominator to 0 and solve for x. So we get x is equal to 2. Thus, the domain will not include 2, so x is not equal to 2. The domain of f is equal to all x values such that x is an element of real numbers excluding 2. To look for the y-intercept or to get the y-intercept, we let x be 0. F of 0 is equal to 2 times 0 minus 1 over 0 minus 3, which is equal to negative 1 over 3, which is equal to 1/3. Oh, let me have the correction. This is supposed to be 3 times 0 minus 6. So our y-intercept is negative 1 over 6. This should be 0, negative 1 over 6. My mistake. Now let's proceed to zeros. To get the zeros of the function, we let the numerator be equal to 0, or we equate the numerator to 0. Thus, we get 2x minus 1 equals 0, x is equal to 1/2. Thus, we have the x-intercept to be 1/2, 0. All right? Now, this time, we are going to get the asymptotes. To determine the asymptotes, we need to check first if there is a vertical asymptote. Again, a vertical asymptote exists if there is a value of x where the denominator is equal to 0. We have already figured that out in figuring out the domain. So, usually the exception in the domain is the vertical asymptote. So, in this case, our vertical asymptote is the vertical line x equal to 2. Now, let us see if this function has a horizontal asymptote. Looking at the function, the highest degree of the numerator is 1 and the highest degree in the denominator is also 1. Since they have the same highest degree, or if they have the same degree, the degree is equal in the numerator and in the denominator, we use y is equal to the ratio of the leading coefficient. Thus, we have y is equal to 2/3. The leading coefficient of the numerator is 2. The leading coefficient of the denominator is 3. This horizontal asymptote is also the one that we will use to determine the range. Since there is a horizontal line for which there is no y value, this would give us the restriction of the range. Thus, our range is the set of y values such that y is an element of a real number except 2/3. Now, note, look at the domain and range in finding the asymptotes. All right. Next part is to construct the table of values as seen here. Now we are ready to sketch the graph. The steps might be lengthy as you have noticed, but this will ensure that it will be easier for us to graph the rational function. You will see in the following explanation. So to graph, the first thing that we will plot is the horizontal asymptote. This is our y is equal to 2/3. Actually, you can also have the vertical asymptote at the first, but it is nice to plot the asymptotes first so that you will know where your graphs will cross and where your graphs will not cross. Recall that an asymptote is a line where the graph gets closer and closer to it but never touches it. So the horizontal asymptote is graphed with a broken line, as well as the vertical asymptote. The oblique asymptote is also graphed as well. Note that when there is an oblique asymptote, there is no horizontal asymptote, and when there is a horizontal asymptote, there is no oblique asymptote. Next is to plot the points that we have in our table of values. Here are our table of values. We can plot the points. Plotting the points, we can see that it is only on the lower left and on the upper right. We also plot the points on the upper right. After plotting the points, we connect them, thus forming this curve and that curve. We now have the graph of our rational function. Now it's time to apply what you have learned about rational equations and inequalities in this activity, activity 3. Pause the video to give you ample time to answer. Check, check your solutions or to self-check your solutions, your answers should be x equals -1 in number 1, part 1, and x less than 2 or x greater than 3 in number 1, part 2. If you got both numbers right, then you can now proceed to the second item in each part. Activity 4. Now it's time to apply what you have learned about rational functions in this activity. Again, pause the video to give you ample time to answer. Self-check your solutions. To self-check your solutions and your answers should be if you got all the answers right, you can now proceed to the second item. Activity 5. Now it is time to apply what you have learned about rational functions in real-life word problems. Pause the video to give you ample time to answer. Self-check your solutions. Your answers should be series bus speed equals 60 kilometers per hour, while minibus speed is 40 kilometers per hour. If you got all the answers right, you can now proceed to the second item. This time, you are going to transfer your understanding to real life situations. Here is another activity that will help you apply your learning about concepts of rational function, equation, and inequality in real life situations. You are to write a journal, create real life situations where knowledge of rational function, equation, and inequality can be applied. I would suggest that you give two real life situations of your choice, either a rational function and a rational equation, a rational function and a rational inequality, a rational equation, or a rational inequality. It's up to you. The rubrics for scoring will be 5 points for exemplary explanation, detailed and clear. Examples may have been provided. The reader can follow the flow of the concept, proper use of punctuation marks, and following the subject verb agreement. That's 5 points for each criteria for each real life situations for a total of 30 points. What we have learned so far, let's try to check. Represent real life situations using rational functions. Check. Distinguish rational function, rational equation, and rational inequality. Check. Solve rational equations and inequalities. Another check. Represent a rational function through its table of values. Graph and equation. Yes, we have done that. Find the domain and range of the rational function. Check. Determine the intercept zeros, asymptotes, and rational functions. And lastly, solve problems involving rational functions, equations, and inequality. If you think you need to watch the video all over again to get the full grasp of the concept, well, that is the very main reason why I made this video, so that students can watch the discussion again and again up until they have mastered the skill. Not everyone has the same pace in learning, so be patient with yourself if you have to watch this video more than you expected to. That's all right. That's part of the learning process. Achievement unlocked. Congratulations. Bravo. To the rational mind, nothing is inexplicable, only unexplained. Don't forget to comment down below, like and subscribe, and stay tuned for more general mathematics videos. See you next time. Once again, this is Teacher Karie. Bye!